Okay, now we will discuss the topic and discuss the concept of IS system of limits and fits. What is that IS system? IS represent what? Indian standard. That is IS standard number is what? 919 to 1993. The system of limits and the fitters comprises with the 18 grades of tolerance, 18 grades of tolerance and the 25 types of fundamental deviations. So we have what? 18 grades of tolerance and the 25 types of fundamental deviations. Okay, and they are also and they are also indicated with respect to what the capital and the small letters. And for wholes the letter symbol is what? Capital A to capital Z suffix C. And for the shaft the letter symbol indication is what? Small a to small zc for the represented by the small letters. And the diameter steps ranging from 1 mm to 500 mm. The diameter steps diameter from 1 mm to 500 mm. It's around the this is what the letter symbols for the both the holes and the shaft. For the shaft diameter, it steps ranging from what? From 1 mm to the 500 mm. So now here we are recommended only the unilateral hole system. We are recommended what? Unilateral hole basis system is recommended. We are discussed earlier the both the unilateral and bilateral. This one may also be used. Earlier we are used the both. We have discussed the both bilateral and the unilateral shaft basis system. Now we have another one concept here is IT grade. IT represent what? International tolerance grade. It refers to what? It is used in the industrial industrial process, and these grades are used in designing a parts with desired specification. Designing parts with a help in designing parts with desired specification. So for that reason we are using a concept called IT grade. IT represent what? International tolerance grade. Here IS represent what? Indian standard, that is what? IS 919 to 1993. Now we have 18 grades of tolerance. One is what? IT 01, IT 0 and IT 1 to IT 16. So IT 01, IT 0 and IT 1 to IT 16. So these we can call it as a what? Standard tolerance. These we can call it as a what? Standard tolerance. So we can call it as a grades. 18 grades of tolerance also called as what? Standard tolerance. So for grades IT 5 to IT 16, the standard tolerance limit, it is represented by small I, and we can come up with a formula for I is equal to what? 0.45 cube root of capital D plus 0.001 0.001 into D microns. So where D represent what? Geometric means of two diameters in mm. Geometric means of two diameter nothing but what? Both we are having a two diameter. We will come to the two diameters. One is what? Minimum diameter and the maximum diameter. So that represent, it is used when D is what? Less than or equal to 500. If the value of the D is greater than the 500 mm, if the value of the D is greater than the 500 mm, then the standard tolerance limit I formula is what? 0.004 capital D plus 2.1 micron. This is the two formulas which is used to find out the standard tolerance limit. Now then I will share the grades of tolerance and the grades of tolerance that we have discussed. We have mentioned here, right? IT 01, IT 0 and IT 1 to 16. These tolerance grades in microns, that values and formulas, that I will share it in the WhatsApp group. Now we will discuss the what is meant by hole, how the hole is denoted by, how the hole, shaft and fits are denoted by. So hole is denoted by what? H6, for example we are taking H6, H8, etc. It is denoted by what? Capital H with respect to numbers, with respect to numbers. So appropriately what it is, what with respect to what? Capital letters. So what about for the shaft? Earlier we have discussed the hole is what? For capital letters. Earlier we are use it for what? Holes is equal to capital A to capital Z, and for the shaft small a to small zc. Yes or no? Same like that of here also, hole can appropriate for capital letters and appropriate small letters can be used on suffix. And earlier we are using suffix as a numbers. You are using suffix as a numbers. Now we will discuss the what is meant by fit. Fit is nothing but what it is represented by the basic size common to both components, and it is common to both components and followed by the symbol corresponding to the each component. So corresponding to the each component, it is represented by what basic size common to both components and the followed by the symbol corresponding to what each component, that is represented by wholes is always written first. So for example, we have taken it as what 35 H8 F7. So 35 H8 F7, what does the 35 represent? It is the value of what basic size. You are all familiar with the basic size, right? We have discussed the basic fundamental definitions. There you will know the basic size, and also we have written the hatched line that is attached to the lower deviation line earlier in the earlier concept of hole basis and the shaft basis system. So here 35 represent what value of the basic system, and capital H represent type of hole, that is hole basis system, and 8 represent what IT represent what international tolerance grade. IT 8 grade of tolerance for hole, this is for hole. And 7 represent what IT 7 represent for what, for shaft, tolerance for shaft. And F represent what, F represent the type of a shaft, F represented what type of the shaft. So this is what the representation for what representation of fit. Okay, now we are having a we are having a positions of limit nearest to the basic size are given by the letters. So now the how the positions of the limits nearest to the basic systems are given. So whole can be represented by what capital A, capital B, capital C up to capital Z, ZA, ZB, ZC. And shafts represented by what small letter, nothing but what H represent what shaft H is basic, and fundamental deviation is what 0. So here how the fundamental deviation is 0 means, for the unilateral hole basis system is selected, then the whole H is what capital whole H is what basic, whereas the unilateral shaft system, the shaft small h is the basic system. So in both the cases the fundamental deviation is 0. So this can be referred with respect to what unilateral hole and shaft basis system. Now then again I will share another one photo regarding the representation of what positions of the fundamental deviation. I will share it in the WhatsApp group, the positions of the representation of the representation of the position of the fundamental deviation. In that figure, just I will show it in the textbook. Before going to that one, just I will just briefly overcome the regarding the figure. So in that figure we are representing what A to G. We are representing in the figure, it will clearly show that capital A to G is what oversized hole, and for shaft small a to small g is undersized shaft. Arrangement can be symmetrical for about the basic size. In the from it is clearly that capital A to G is what oversized hole, and A to small g is what undersized shaft. And hole A and shaft A have the largest fundamental deviation, and always it is the hole can be represented by positive, hole being positive and shaft being negative. So having the largest fundamental deviation. So capital A and small a, hole A and shaft small a having a large fundamental deviation, it is represented by hole is what positive and the shaft is what negative. And another one, the first 8 designation. So in that we are having from capital A to capital ZC, right? Whole representation. The first 8 designation represent a clearance fit. First 8 represent what clearance fit, and that from small js, that is js, from capital JS to ZC represent what interference fit, and small js to small ZC represent where transition fit. For holes, the upper deviation can be represented by the capital ES, and for lower deviation can be represented by the capital EI, and for the shaft upper deviation can be represented by small es, and the lower deviation can be represented by ei. Now I will show the this one figure. Just I will share it in the WhatsApp group. See here, in this one we are representing, but this is what the representation of the positions of the fundamental deviation, where we are representing what here capital A to capital J. It can be represented by what EI. What does that EI represent? What does that EI represent? Where it is represented by what? Hole's upper deviation. EI represented what? Lower deviation. So there is interference, and we are represented with interference and the transition fit. And capital ES represent what? For the shaft, ES represented what? For the holes it is what? Upper deviation, and for the lower deviation is what? Capital EI. Here see, up to A to JS and J to ZC, this is represented by ES. This is what is zero line representation. This is what the fundamental deviation, that is positive and the negative. For the capital A, for the hole it is positive, and for the shaft it is for fundamental deviation is negative. That one only we have discussed in the earlier. Now we will discuss the concept of what? Both hole and the shaft designation system. It is very important. So for example, we have taken 50 H, capital H suffix G bar small g suffix 7. What is this overall representation? How we are finding out how we can understand the hole and shaft designation system? Just I will give you one example. Take example is 50 Hg and small g 7. Here 50 represent what? Basic size of the shaft. This is what the basic size. 50 represents what? Basic size of the shaft or hole. Then capital H represent what? Hole, and small g represented what? For shaft. So capital H represent a position of the tolerance zone for what? Hole. Position of tolerance zone for hole with respect to zero line, and G represent what? Position of the tolerance zone for shaft with respect to zero line. So here H, G and H8, I forgot to write, H8 and G7. 8 represent what here? Tolerance size of the hole, tolerance size of hole, and 7 represent tolerance size of the shaft. So this is how we can understand the designation system for both hole and the shaft. Now I will tell you how to procedure to solve the problems of limits, fit and tolerance. We can expect one problem related to this one in the procedure for solving the problems of limits, and in the next videos we come to know what is the gauges, what are the different types of gauges, how to design a gauge. Compulsory question we will expect from the design of the gauge, and here also we can expect one problem related to the procedure to solve the problems on the limits. To solve the problems, we are having a 3 steps. So in the step 1, to calculate the tolerance unit, that is tolerance unit means nothing but what I already mentioned right here, the standard tolerance limit I. If the D is less than or equal to 500 and it is D is greater than 500, what is the formula here? And if D is less than 500, what is the formula? You are represented here, right? So the based on same formula we can easily represent with respect to microns. Okay. Now to calculate the tolerance limit, first step is what? To find out the minimum and the maximum diameter. To find out what? First minimum and find out the minimum and maximum diameter with respect to what? Basic size of shaft and hole. This is what the first step, to find out the minimum and maximum dia. We have the various diameter steps specified by the Indian standards, that is 1 to 3, 3 to 6. It can be given in the problem, no issue. Now in that step 1 second step, to calculate the geometric mean diameter, to find out the what? To calculate the geometric mean diameter, capital D. To find out the geometric mean diameter, capital D, with the help of what? Minimum and maximum diameter step, the geometrical mean dia, the capital D formula is equal to what? D is equal to square root of D minimum into capital D maximum. So after calculating the geometrical mean diameter, then we can easily find out you can easily calculate the tolerance unit, that is what? Tolerance unit, that is small I. If T is less than or equal to 500, we are having one formula, that is I is equal to 0.45 root cube root of D plus 0.001, only 0.001, and here 0.004 D plus 2.1 if D is greater than 500. Now this is regarding the step 1. What is that? Minimum and maximum diameter with respect to what? Basic size of shaft, and to find what is the various diameters, and to find out the geometrical mean diameter, and then calculate the tolerance unit, that is I. Then in the second step, to calculate the fundamental deviation. To calculate the fundamental deviation, that is to calculate the fundamental deviation F. For example, for D, if we have taken for example capital D is the whole, for D whole, the fundamental deviation F is given by F is given -11 capital D point to the power of 0.41. Okay, this is the way of calculating the for the D whole. Okay, the fundamental deviation is already given. For example, if it is for capital D, for the given data, it is given in the with the help of given data. With the help of given data, you can easily find out the fundamental deviation. Now for the whole, then this is regarding the step 1 and step 2. Now for whole, this is we are having a 2 step over. For whole, step 3, to calculate the upper limit and the lower limit. So upper limit and the lower limit. Upper limit in the base, while discussing the basic definitions here, we are representing the upper deviation, upper limit. So UL, upper deviation, lower deviation, maximum limit, minimum limit, like that we have discussed, right? So based on this one, to find out the upper limit and the lower limit. To calculate the lower limit size, first for whole, and we will discuss for whole and for the shaft. If it is for the whole problem related to whole, we can solve these 3 steps, and related to the shaft, we can discuss these 3 steps. Okay, for the step 1, to calculate the lower limit of size for whole. To calculate lower limit of size for whole. So lower limit is equal to what? Basic size plus fundamental deviation. This is the formula for to calculate the lower limit size of the whole. And this is a step number 3, sub step 1. It is related to the whole. What is the lower limit formula? Basic size plus fundamental deviation. Next, for the step 2, to calculate the standard tolerance for whole. To calculate the standard tolerance for whole, as per the grades of tolerance, we know the grades of tolerance, that is IT 0, representation, right? Where we are represented here, we are represented here, right? IT 0, IT 01, IT 0 and IT 1 to IT 16, based on the IT grade, based on the tolerance grade, with respect to the table. For example, say whole is with a grade tolerance of 8, and nothing but what for that 8 number whole grade tolerance 8, we are having some value, some tolerance limit value, I value. For that, standard tolerance is what with respect to that data, that is for example, if I taken with respect to grade is equal to 8, that for that 8 tolerance grade 8, the value is what? 25i. Based on that, with respect to table, we will come to know what is the standard tolerance for that whole, we can come to know. Then after calculate the standard whole, last limit is parameter is what? Upper limit. To calculate the upper limit of size for whole, so the upper limit value is what? Lower limit plus standard tolerance. So the lower limit plus the standard tolerance. This is the formula for what? Calculating upper limit. So lower limit is equal to what? Basic size plus fundamental dimension. To calculate that standard tolerance, we are having with respect to grade, with respect representation in the table. For that respective grade, we are having separate value, standard tolerance value. After finding out that standard tolerance in the table, we can calculate the upper limit of the size for whole. What is the upper limit formula? Upper limit is equal to lower limit plus standard tolerance. This is regarding the for the whole. If the problem related to the shaft, same concept we have to find out here. To calculate the upper limit of the size of the shaft. There is vice versa. Upper limit size of the shaft. So upper limit formula is equal to what? So basic size plus fundamental deviation. And the second step is what? Calculate the standard tolerance for shaft based on this one. If it is with respect to 7 or 8, with respect to tolerance grade, we are having a value called 16i. Like that, we will come to know in the table. And in the final step, to calculate the lower limit of size for shaft, we are having one formula, that is lower limit is equal to what? Upper limit minus of standard tolerance. Lower limit, upper limit minus of standard tolerance. Why it is vice versa, we come to know in the gauges. While solving the problems in the related to the gauges, we come to know why it is, why the both for the why it is vice versa for both the hole and the shaft. So for the shaft, what? First to find out the upper limit, that is basic size plus fundamental deviation with respect to tolerance grade. For the shaft, with respect to that tolerance grade value, we will come to know the value of the standard tolerance value. After that one, to calculate the lower limit of size for the shaft, that is what is the lower limit is equal to what? Upper limit minus of standard tolerance. So only the difference is what? Here for hole we will calculate with respect to lower limit, standard tolerance and upper limit, and for the shaft we will follow the upper limit, standard tolerance and the lower limit. This is what the vice versa. So this is how, once again I will repeat it briefly. First step one is to calculate the tolerance unit. In that tolerance unit, initially we will find out the minimum and maximum dia, and with respect to basic size of shaft and hole, what is the mean dia formula. After finding out this one, find out the tolerance unit. Once you find out tolerance unit, you can easily find out the fundamental dimension with the help of what? Given data. And with respect to the problem is related to hole, we can find out the upper limit and lower limit. If it is shaft, and here also we will find out the upper limit and lower limit. For the hole, from lower limit initially we will find out, and upper limit on the, after that lower limit we will find out the upper limit. And for the shaft, initially we will find out the upper limit, after that we will find out the lower limit. In the next video we will solve the problem related to with respect to one hole and with respect to one shaft. Okay, thank you.